right, section 1.6, video part 1. In this particular section, we're going to sort of revisit a topic that we've already covered, but we're going to revisit it with a little bit different slant to it. But before I even get to that, let me tell you this about this section. We're going to learn how to solve two kinds of equations in this section that we have not talked about. You know, we talked about linear equations where you get your x's on one side, numbers on the other. We talked about quadratic equations. We talked about exponential equations in chapter 4. We talked about logarithm equations, how to solve those. So we're going to talk about two other kinds of equations in this section and learn how to solve them. One is going to be called radical equations. We will cover those last. And the type of equation we're about to solve now is called rational, R-A-T-I-O-N-A-L, rational equations. Now, the word rational just simply means this, fraction. So we're going to talk about solving equations with fractions. Now, we've already done that early in this course. As a matter of fact, the very first section that we covered, section 1.1, we learned to solve linear equations with fractions in it. Let me remind you, you don't have to write this down. X minus 3 over 2 plus 1/3 equals 2x. Okay. This is an equation with fractions. All right, now let me remind you of how we solved these. What we did was we found the LCD, and then we multiplied through by the LCD to clear the fractions. So, for instance, in this problem right here, you got a denominator 2, denominator 3, denominator understood 1. That denominator over there is 1. You don't have to write this down. The LCD here is 6. And so what we said we were going to do is multiply through by 6 to clear the fractions. Now, whenever we multiply through by 6 to clear the fractions, remember you have to multiply every term by 6 to clear the fractions. So put a 6 by this one, 6 by this one, and a 6 by this one. And you may or may not remember me saying this on this video, but I did. Every single time we got to right here, I would say cross cancel first. In other words, cancel out your denominators. So we're going to mark out 2 into 6 goes how many times? 3. 3 into 6 goes 2 times. There's no canceling over here. So 2 into 6 is 3. And then 3 into 6 is 2. But when you cancel this 2 into this 6, and it leaves 3, that 3 multiplies everything that's left. So that gives you 3x minus 9. And then this 3 into this 6 leaves 2. 2 times 1 is 2 equals 12x. And then 3x minus 9 plus 2 is minus 7. Then I just moved the 3x over to the right side. 12x minus 3x is 9x equals negative 7. And then divide to get the solution. That's how we solve that equation. Now, in this particular section, we're going to revisit equations with fractions. But it's going to have a little bit different twist in it, and it's this. The fractions that we're going to look at now are going to have variables in the denominator. This didn't have a variable in the denominator. So it's still rational equations, but it's the types of ones we've never looked at before. We didn't look at any in that first section where the x was in the denominator. So that's how these problems will look. So just to give you a visual, don't write this down. Let me just hop ahead and show you an example we're going to do in just a minute. This problem right here. Does this equation have fractions in it? Yes, it does. But the difference is it has variables in the denominator. Now, how does that impact how the problem is worked? It does not impact the process. We're still going to find the LCD, and we're going to still clear the fractions. But here's the difference. And then this goes back into something else that we talked about before. Remember whenever we were talking about domain, and we said that you cannot allow anything that causes your denominator to be 0. So what we're going to have to do in these problems is, since your x's are in the bottom, we're going to have to make sure that our answer doesn't cause our denominators to be 0. We're still going to find the LCD, and we're still going to clear the fractions. We just have to make sure that none of the denominators become 0 once we find that final answer. Now, your LCD is going to look a little different because not all of your denominators are just numbers now. Your LCD, like the LCD between 3 and 4 is 12, but there's no x there. So in some of these, our LCD will have an x or may have other stuff in it when we get rid of our fractions. Okay, so let's barrel off into two. We're going to do 2 or 3 of these problems in this section right here. All right, so let's solve this. Okay. Now, here's the first thing that I want to ask myself in solving this equation. What value of x makes the denominator be 0? I mean, that's what I'm thinking in my head. Okay. Now, there's no x in this denominator, so there's no worry. There's no x in this denominator, so there's no worry. But there's an x in this denominator. So, what number could you put right there and it would make that bottom be 0? Well, just 0. Now, look right here. What number could you put for x right here that would make this denominator be 0? 3 times what is 0? 0. So, the same number for x makes this denominator 0 as this one. So what makes the denominator be 0? If x is equal to 0. We call this our restriction. In other words, that's the number that you cannot let x be. Now you say, well, what's x going to be? Don't know yet. We haven't found the answer out yet. All right, so let's go back to the problem again. Okay, what's our restriction? X equals 0. Now, let's find the LCD. All right, let's look at what we've got to get rid of. A 6, this is understood 1. A 6, a 1, a x, and a 3x. Well, what does 3 and 6 both go into? 6. But you also have to have an x because you got an x here and you got an x over here. So your LCD is 6x. Now, let me show you how you can tell that you got the right LCD. Multiply by 6x. Okay, so I want to multiply every one of these by 6. I keep forgetting to bring that extra color pen in here. Okay. All right, so here's what I'm going to do. I'm going to multiply by 6x. So I'm going to put it there, 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 and there. Now, here's how you can tell if you've got the right LCD. it should get rid of every one of your fractions. There should be no fractions left. Okay? So this x cancels with that x. There's no canceling here. This x cancels with that x. That 3 cancels with that 6 and leaves 2. And then this 6 cancels with that 6 and leaves 1. All of the fractions are gone. Now multiply what's left. 6 times 5 is 30 plus 24x equals 2 times 2, which is 4, plus 25 times 1 is 25x. Now, I'm going to get the numbers on the left side and the x's on the right. You know that it doesn't matter how you do that to get x equals 2, 26. And all you got to do is when you solve this, you just got to make sure that that is not what your restriction was. Okay? Let's do another one. All right, first, what makes the denominator 0? Well, nothing over here. What value of x would make that denominator be 0? 7. What about this one? 7. So, that is not your answer. That is your restriction. Remember the domain, you can't allow any number that would cause the denominator to be 0. So the domain here is all real numbers except 7. It's tied in with what we did earlier. Now, find the LCD. Well, the LCD is easy here. Why? Because what's in this denominator? X minus 7. What's in this denominator? X minus 7. So your LCD is going to have to be x minus 7. Now, what do I do with that LCD? You multiply by every term. And that's the key. Is you have to multiply by every term. When you do, this cancels with this one. This one cancels with that one, and so you're left with x equals 7. Now be careful right here. This is over 1, but this 8 has to distribute to both of those. So that's 8x minus 56. Now get your x's on one side. Get your numbers on the other. So subtract the 8x across. You get x equals 7. But remember, 7 was the only thing x could not be. It was our restriction. And so since this is the answer that I found, and that was my restriction, the answer to this is no solution. But see, had I not checked that against that restriction, I would not have known that. Okay, let's do one more example. Now, just a suggestion here on this one before we get started. If any of your denominators are factorable, it will be easier on the eyes if you will factor it first. For instance, this denominator right here, x squared minus 9 factors as x plus 3 times x minus 3. It's just easier to look at if it's factored. Okay, now, what makes this denominator 0? X equal negative 3. What makes this denominator 0? X equal positive 3. What makes this denominator 0? Negative 3 or positive 3. So these are my restrictions. Now, find the LCD. The LCD, you got to get rid of an x plus 3, so you got to have that in there, but you got to cross out an x minus 3. That's completely different. So you have to have an x plus 3 and an x minus 3. Now, when you get to this over here, you already have both of them. So the LCD is x plus 3, x minus 3. Now, go to your original problem. And multiply through by x plus 3, x minus 3. So do that here, x plus 3, x minus 3. X plus 3, x minus 3. X plus 3, x minus 3. Now let's cancel what we can. Well, on the right side of the equal, both of them cancels and just leaves 18. But look at what's left on the left side. On the left side, the x plus 3's cancel, but you're left with the x minus 3 that you have to multiply by that 3. When you do, that is distributive property. So it's 3x minus 9. Same thing right here. The x minus 3's cancel, and so you're left with 1 times x plus 3. When you distribute that, it's just going to be x plus 3. Now 3x plus x is 4x. Minus 9 plus 3 is minus 6 equals to 18. Add 6 to both sides to get 24. And divide both sides by 4 to get x equals 6. That is not a restriction. So that is your solution to this rational equation. So this is solving rational equations with variables in the denominator. I told you that there's two kinds of equations that we're going to be solving in this particular section. One is rational equations with variables in the denominator. We just did 3 of those. The next type will be coming up in the next video.